MySage stands for My Sustainable Agriculture Greenhouse Ecosystem, a concept to reduce the carbon footprint and greenhouse gases, mainly addressing the 13 sustainable goal climate action and touches on 2 other sustainable goals: 12, responsible consumption and production, and 7, clean and affordable energy. My concept model is an onion eco-greenhouse, which focuses on utilizing its waste to be converted into biofuel. This is supported by 2 other alternate renewable energy and rainwater harvesting systems. Here is the overall design project, the Onion Eco Greenhouse project. This model integrates 4 systems: the biofuel, wind turbine, solar energy, and rainwater harvesting system. With how greenhouse gases affect our world in this climate change accident. These jars represent 3 different scenarios: rainforest, control, and our Earth's current state, with excessive carbon dioxide invading our atmosphere. With this experiment, we used carbon dioxide, which I made from mixing baking soda and vinegar together. Gas emissions as what you see in this jar: animals, machines, vehicles, humans, and their activities. I took the temperatures of these 3 jars, with the lamp as the sunlight and the black cloth as the ground. Jar 3, which is our Earth right now, has the highest temperature because there is carbon dioxide present and reacts when exposed to the sun's radiation, thus causing global warming on the Earth's surface and atmosphere. This is where we need to take action to reduce global warming. Welcome to MySage. This greenhouse is built by me. Ta-da! This is called an eco-greenhouse that is self-sustaining. It has LED lights and pumps generated by 3 renewable energy sources, biofuel being the main source, and the other 2 alternate ones are the wind turbine and the solar energy system. It also has a rainwater harvesting system. Just look at the water sprinklers. Here are my onions and some complementary herbs. This commercial farming is for sale in the mass market. Onion farming has one of the highest waste that contributes to landfills and greenhouse gases. Let's take a look at how I put the greenhouse together. The best material to use for the glass house is acrylic. It is strong and durable, and it is cost effective, lasting for more than 20 years. This greenhouse prototype helps to increase agricultural productivity and maximizes profits by its efficient and controlled environment. Less landfills and less space, less soil pollution. However, it is important to plan the precise design of the greenhouse and be invested in the idea, as the initial cost can be expensive. A very beneficial way is to convert onion waste into biofuel for electricity. This is the next most important feature in my concept model. Here's how it works. The onion waste is juiced and the sulfur is removed. Then, it is mixed with water and goes in an anaerobic digester where bacteria consume the sugars in the juice. One of the byproducts is methane, and its hydrogen is extracted from methane to be processed into the 300 kilowatt fuel cells, thus producing electricity. I built a prototype of how an onion can produce electricity. There were 2 experiments to test the amount of electricity able to be produced by the onions. As you can see here, 1 onion produces 1 volt of electricity, whereas 4 onions produce 4 volts of electricity. This confirms my hypothesis that the more onion waste is used, the greater the energy it produces. Did you know that wind turbines are different from windmills? Both produce electricity. Windmill uses the gear concept, and the wind turbine uses a gearbox and generator to convert the slow rotation of the blades into higher speed motion, turning the shaft fast enough to generate electricity. My wind turbine prototype system consists of the wind blades, a stand, and the dynamo. The dynamo creates electricity to power the greenhouse LED lights when the rotor cuts through the magnetic lines caused by the stationary magnets in the dynamo. It transforms wind-kinetic energy to mechanical energy to electrical energy. Essentially, the faster a wind turbine spins, the more energy is produced. Something I noticed while testing my wind turbine. It was harder to turn it when more voltage was required to light up the light. This is because the heavier the voltage load, the more effort required to turn the dynamo shaft to generate that more electricity. Here we have the solar panels, which is part of the greenhouse. Do you know how it works? They contain silicon photovoltaic cells that absorb the sunlight radiation. The energy is transferred through photons and electrons into an inverter to be converted from DC to AC electricity. Here's how this prototype can help to generate electricity to the farm to power the sprinklers and the LED lights and the water pumps. Solar energy is clean energy, durable, long-lasting, and becoming more affordable due to the increasing awareness about it. Look at the fascinating water sprinklers. These water sprinklers are powered by the water pump, by the 3 electrical energy sources that I have in this model. Rainwater harvesting is stimulated here by the water sprinklers. Look at these gutters. The rainwater falls down into the gutter and flows into a catchment area. Water is recycled for irrigation. This self-functioning system saves a lot of time and effort instead of using human labor. Our country's climate conditions are suitable for onion farming, moderate weather that can support the onion plantation and produce renewable energy sources. I believe that my SAGE concept will influence other agriculture industries and companies locally and internationally. More people will be well aware and informed of this agroecology topic and biofuels for a more sustainable future. And hopefully, we together can act responsibly to propel towards achieving the targeted SDGs and its visions by 2030. Thank you for sticking around and click on the link in the description for further information about my project.